I am Mr. Ish. Good evening. Thank you for joining me. We're looking here at binomial terms. We look at two questions. We have a specific binomial, a minus b all to the power of 5. We have to find the third term. If this were to expand, there would be a specific number term here. The third term, we have to find that. Just remember this exponent over here. You look at that exponent n plus 1, it gives you a 6 because you're looking at a 5 plus 1. There would be 6 terms if you were to expand this. From that 6 terms, we were looking for the third term. How do you go about doing these type of questions? You focus in on this. Let this represent your nth term. To determine this, you're looking at your term, which you're looking for is n minus 1. And here that translates into 3 minus 1, which is really 2. You're looking here at a value of 2. Then you gotta set this up in terms of a combinatorial coefficient like this n and r. And then of course you're gonna have to bring in everything over here with regards to exactly what you see an a and a b term. How do you go about setting this up? Well, you're gonna look over here at n minus r, and here you'll put r. And that's exactly what you're gonna have. N over here is gonna be what? This right here is your 5 right here, which is your n. Your n value here is gonna be your r value. That's how this is gonna play out. We have 5 over here coming on the top. We have a 2 over here on the bottom. Then we have a over here, 5 minus 2, we have a 3. And then we have over here a b, which will be a 2. What will happen with regards to sign? Whenever you have a binomial with a minus, it always alternates between positive, minus onwards. And we'll figure out the sign at the very end. When you're looking at this, you gotta evaluate this, you have to evaluate this. These are easy. This right here is a little tricky. You have to remember the rule. The rule over here is n factorial over r factorial, n minus r factorial. When you evaluate this, you're looking at a 5 factorial divided by 3 factorial, 2 factorial. Then you have an a cube and you have a b square. When you evaluate this, it's not too hard. You can do it all in the calculator, or you can cancel things out. I'll just do 120, which is 5 factorial divided by 6 divided by 2. 6 is 3 factorial. We get a 10 over here. Our answer here is 10a cubed b squared. But now we have to determine the sign. We're looking for the third term. This is my first, my second, my third. The third term will be positive. Our answer here will be 10a cubed b squared. So you've seen how this played out. The number item here you have in terms of your exponent is your n. And they're always n plus 1 in terms of total number of components as it were to expand. What you're looking here for the specific term, you do n minus 1, that gives you your r value. And everything follows here with this formula nr, this component n minus r and that component r. And this right here is your combinatorial coefficient, which comes out through this. It's basically, you're looking at right here is an NCR, like that. NCR, a combination formula right here. NCR, and this right here is a formula for that. And you've seen how everything played out right here. 2a plus b all to the power of 7. We have to find the 6th term. You have an n value here of 7. It would really mean you have 8 total terms if you were to expand it, because this right here, you add 1, gives you the number of terms when you expand it. With regards to this, we're looking for the 6th term. You do n minus 1, and that would be 6 minus 1. You're actually looking here for a 5. With regards to your r value, you're looking here at a 5. The formula again, or I wouldn't say this is the formula, I would say this right here is your setup over here. 2a, you're looking here at n minus r, and then you're looking at b, and this right here is your r. This could have been x and a y, 2x plus y. You could use any letters, any variables. I'm just using a and b. The formula for this is n factorial or r factorial, n minus r factorial, because that represents here a combinatorial coefficient, NCR, and that's how it plays out. We now know what our n value is 7, we know what our r value is 5. We have to plug everything here. 7, 5, we're looking here at a 2a, and then n minus r, 7 minus 5, which is a 2. We're looking here at a b, which is your r, 5. You have to expand this out in terms of computing it. 7 factorial is a 5040 divided by 5 factorial, which is 120, divided by 2, because it's all of this. You'll have a 21 over here. 21. You can always compute this again on your calculator. Then you have a 2 square, which is a 4a square, and then you have a b to the 5. As a part of your last step, now you just bring everything together. You have 21 times 4, and that's going to be an 84. you have a square b to the 5, and that right there would be your final answer, 84 a square b to the 5. A good way to think about everything here, if you're looking at a and b in terms of your bases, and then you know you have the exponents, everything in terms of your first variable starts from your highest and then it goes to 0. Your a in terms of your exponent will start out in the first term with an exponent of 7, then it'll go all the way down to 0. B will start out with an exponent of 0 and will increase gradually up to a 7. Everything is sequentially going by 1. If you're looking here at basically the sixth term, which is number 5, you have in between here 7, 6, 5, 4, 3, 2, 1, 0. You're looking at the third last term. So you know you have a 0, then you'll have a 1, then you'll have a 2 in terms of A. Here you'll have a 7, 6, and then a 5. So that tells you A will having an exponent of 2, B will be having an exponent of 5, and you see exactly that come into play. You can always think about things in that way, but always keep in mind your first term will start with the highest exponent and it will go down to 0 with each term of your entire expansion. Your second term will start with the exponent of 0 and it'll go all the way up to 7 for your highest value, your n value, sequentially by 1. Generally, that is the trend in these type of binomial expansions. Anyhow, that's it for this video. Thank you. Have a great day. Bye.